Last but not least is the standard score. So the standard score allows you to compare data sets of different magnitude in a very systematic approach. For instance, if we're talking about different test scores, and I create a test that's out of 100 points, but another teacher creates a test out of 1,000 points, what we can do is we can standardize those two scores and then compare how somebody did on those two tests by their standard score. Another name for a standard score is a z-score. And we will use this over and over and over again towards the latter half of the semester. So this represents the number of standard deviations a given value x falls from the mean. To calculate it, you take the value minus the mean over the standard deviation. And it's easier to write it in symbols, so it's going to be x minus mu over the standard deviation sigma. So one benefit of a z-score is that it allows us to compare data sets from different data, or compare data from different data sets. For example, it's used to determine what we would consider tall for different genders. A male that is 6 feet tall isn't considered very tall, but a female who is the same height normally is considered very tall, since her height is further from the mean height for females. And what we're going to do is we're going to kind of put that into practice over here, and we're going to calculate a z-score for this example. So for healthy females, the red blood count, which is RBC, and it's measured in millions per cubic millimeter of whole blood, has a mean of 4.8. So right away, when you see a number and you know exactly what it is, so mean is 4.8. I suggest just writing it down. And the standard deviation is 0.3. So sigma equals 0.3. And what we want to do is figure out if 4.6 is considered unusual. And when we say the word unusual in statistics, we're talking about 2 standard deviations from the mean. So that could be either 2 standard deviations above or below the mean. And to figure that out, we're going to calculate the z-score for 4.6. So again, the z-score is the value minus the mean over the standard deviation. The value that we're looking at is 4.6. The mean was 4.8, and the standard deviation was 0.3. Now, if you do this calculation, you get negative 0.67. All right, let's take a step back and think about what the negative means and what that 0.67 means. So the negative, well, we did 4.6 minus a larger number. The average was larger than the value we considered. And so the negative in the z-score just means that the value 4.6 is below mu. Right, that's the only way we can get a negative out of this formula here. And then this 0.67, well, we know that the standard deviation is 0.3, but 4.6 and 4.8 only differ by 0.2. So this means that 4.6 is not even 1 standard deviation away from mu, right? If we ended up getting, say, positive 2, that would mean that our value was a full 2 standard deviations above the mean. If we ended up getting a negative 1, that means that the value we were looking at was exactly 1 standard deviation below the mean. So the sign tells you whether you're below or above the mean, and the number part without the positive or negative, just the number itself, tells you essentially how many standard deviations you are away from the mean. So a negative number is you are that many standard deviations below the mean.